All right, welcome back. Last thing I just want to mention with this one before we move on to something a little bit more interesting is, again, what this means here when you have tan theta being 4 over 3 is you're going to have a right triangle and some angle here that you don't know. It turns out to be 53.1. We don't know that yet. And tan being opposite over hypotenuse, which is equal to 4 over 3, tells us that, for example, we could have a side length here of 4 and a side length here of 3, so the ratio between these two sides is 4 over 3. That doesn't mean these side lengths necessarily are 4 and 3, but that we have that ratio. So we could have something where this could be a side length of 8, and this one could be a side length of 6. That same ratio could exist. So any combination that gives you a ratio of 4 over 3 could happen in this triangle right here. And there's a certain angle that creates that ratio. Once we solve it, it turns out to be 53.1. But just so we know what it means to have a tan ratio and an angle there, it's helpful when you're visualizing a problem. Okay, so now let's actually use this to solve some information inside triangles. So here's a typical situation you might see. So we're trying to solve for an unknown value. In this case, we're solving for the angle. And we're given certain information about the triangle. So we're given 2 of the 3 sides here. If we wanted to, we could use Pythagorean theorem there and solve for the missing side, but it turns out we don't need it. The first thing I always do with a trig problem like this, and I suggest that you guys do the same every single time, it avoids mistakes, is to label the sides, adjacent, opposite, and hypotenuse. So in this case, since we're working with this angle right here, the 9 is our hypotenuse. Okay, the opposite of the side that we know nothing about right now, and the adjacent is the 5.6. Okay, so now we need to use a trig ratio to solve for this. Now, keeping in mind that you have 3 trig ratios, sine, cosine, and tan, each of these have 3 unknowns in them. Okay, so for example, if you were to write out here sine theta being opposite over hypotenuse, there's 3 unknowns in this ratio. Okay, we don't know the angle, we don't know the opposite, and we don't know the hypotenuse. This is just in general here, not specifically in this case. There's 3 unknowns here. So when we're choosing a ratio to use, we need to choose a ratio where we know 2 of the 3 pieces of information, which allows us to solve for the third one. So in this case, we're looking for the angle. So our unknown is going to be the angle. So we need to pick a ratio where we know both of the sides over here. Now, sine won't be the right one to choose because even though we have the hypotenuse, we don't have the opposite. I know we could figure out using Pythagorean theorem, but again, we're trying to make your life as easy as possible here. We have the adjacent and hypotenuse, so we got to figure out which one of these ratios we should use to be able to solve for the angle. And in this case, it's going to be cosine, because the cosine of theta will be your adjacent over your hypotenuse, and both of these sides are ones that we know already from what was given. So our adjacent side is a length of 5.6, and our hypotenuse is a length of 9. So the only unknown in this equation is the angle theta. Once we have this ratio set up, we just need to solve for the unknown. Whenever we're solving for an angle here, much like we did back on this slide, we have to use one of the inverse functions. So for us, since we're using cosine, we must solve for this angle. We have to use the cosine inverse, which again should be above the cosine on your calculator, the cosine inverse of 5.6 over 9. And depending on your calculator, you may need to make sure you're using brackets around that 5.6 over 9, or else it'll give you the wrong answer. So you run that through your calculator, and it should give you an angle of 51.5 degrees. Oops, not sure what happened there. 51.5 degrees. Okay, so that's our first trig problem. Okay, moving down, new situation right here. Here we're given an angle, and one side we've got to solve for a missing side in the triangle. Just like always, label your sides first and foremost. So again, you choose what angle you want to work with. You could work with this one, 34 degrees, or you could use the fact that all the angles add up to 180 and find this missing angle right here. Again, let's just make our life easier right here and work with this guy. So the 34 degrees is the angle we're going to choose to work with. That would make the x here the opposite side. The side we know nothing about over here, the adjacent, and the 10 is the hypotenuse. It's across the 90-degree angle. And again, we have to choose a ratio here. So we got 3 ratios to choose from, sine, cosine, and tan. Now, in this case, we know the angle. Okay, so whatever ratio we choose, we're going to know what that theta is. and we need to solve for the opposite, and we have the hypotenuse. So when we're choosing a ratio, we should choose one that has the opposite in it, because that's what we're looking to solve for, and that has the hypotenuse in it, because we know the hypotenuse. So which one of these ratios has an opposite and a hypotenuse in it? Well, in this case, it's going to be sine. Okay, so I'm going to use the fact that sine of 34 degrees is my opposite, which is x, over my hypotenuse, which is 10. And if I tried to choose any other ratio, I'd run into some problems here. If I tried to use cosine, cosine needs the adjacent, which doesn't help me because I don't have it. And tan also needs the adjacent, which I also don't have. Okay, so if issues run into choosing other ratios, this is the only one that we can choose right now that will directly get us to the answer. So we have sine 34 degrees equals x over 10. And just like before, I need to somehow use some algebra to solve for x. So to solve for x here, what I'm going to do, I have x divided by 10. I want x by itself, so I'm going to multiply both sides of the equation by 10. So that's going to leave x by itself on the right hand side of the equation, and here I'm going to get 10 times the sine of 34. And this is something we need to just run through our calculator if we want to solve for the answer. So sine of 34 is something, some sort of ugly decimal, which your calculator will tell you. Multiply that by 10, and I believe we said here to one decimal place, yeah, nearest tenths to one decimal place, so round your final answer to one decimal place, and running that through your calculator should give you an answer of 5.6. Okay, so that missing side over here will be 5.6 units. Hopefully that one went okay for you guys. So now we've solved two different types of problems, one solving for an angle, one solving for a side using trigonometry. Let's move on to the next slide over here. And you've got two examples here. I'd like you to try these on your own. So just start by labeling the sides, set up the ratio that you think will solve for the whatever is unknown, and give it a go. When you're ready to see the answers, unpause, and we'll go through them together. Okay, hope you had a chance to give those a try. Hopefully they went well. Let's run through them. So labeling my sides here, if I'm working with a 52-degree angle, I'm going to have 8 being my opposite, x being my adjacent, and this blank side over here being my hypotenuse. So I have the angle, so I need a ratio where I have both the opposite, because I have the opposite and the adjacent, because that's what I'm looking for. That's going to lead me towards using tan. So the tan of 52 degrees will be O opposite, which is 8 divided by x. What makes this one a little bit trickier than the one we just went through is that now if you look at the equation, our unknown is in the denominator. So we need to somehow get that x out of the denominator. What we can do there is, to clear that denominator, multiply both sides of the equation by x. What that's going to do is it's going to cancel the x over here, so I'm just going to be left with 8. And over on this side of the equation, I'm going to have x times the tan of 52. So the equation looks a little bit nicer now that x is in the denominator. Now, to get to my final answer, as ugly as tan 52 looks, you have to remember it is just a number, right? If I gave you the equation 9x equals 8, you wouldn't hesitate to divide both sides of the equation by 9 to get to your final answer, right? So it's the same idea here. We just have to divide both sides of the equation by tan 52. Tan 52 is just a number. So what I'm going to do, let's pick a nice color here. Let's go blue. Divide this by tan 52 and the 8 by tan 52. And then we'll have an expression we can use to get our final answer. Because now, with those tan 52s having been canceled, x is just going to be 8 divided by tan 52, which is just, again, something you can run through your calculator to get to a final answer. So you can run that through, and it should give you a final side length of 6.3. Oops. Okay, so again, a little bit tricky with the algebra there, but again, remember, we just got to get things out of the denominators. It's a nicer equation to work with, and then you can go and solve the rest of the equation from there. Okay, for the last one we're going to do for today, before I'll give you guys a chance to practice, I'm trying to solve for the angle here. Before I do anything else, I'm just going to label my sides. clear that out of there, get that out of the way. So, working with this angle, I have my opposite, my adjacent. It does seem a little bit tedious to label the sides every single time, I admit, but trust me when I say, especially on a quiz test and it's worth marks, it takes a potential way of making a mistake out of the equation. If you have those sides labeled correctly and you have it written out, it's less that you're doing in your head, right? So I do recommend doing it. It only takes a few seconds. So now, again, I'm trying to solve for the angle here. So I should choose a ratio where I know the other two, where I know two of the sides. So I'm looking for a ratio where I have where I have the adjacent and the hypotenuse, and that's going to be cosine. So the cosine of my angle is going to be 2.1 my adjacent over 40. Now, hopefully there should be some alarm bells going off here and saying that this doesn't seem quite right. And what shouldn't seem right is if you look at the two measurements we have over here, one of them is in centimeters and one of them is in millimeters. So the ratio between these two sides isn't actually 2.1 over 40 because these units are different. So in order for this to make sense, we have to actually convert these to the same units. So you have an option. You can convert the centimeters to millimeters. You can convert the millimeters to centimeters. Whichever one works, you just have to make sure your units are consistent regardless. So I'm going to convert these to, I'm going to convert everything to centimeters. So my 40 millimeters is going to be equal to 4.0 or 4 centimeters. So I'll just make that little change over here in my question. So now the cosine of theta is going to be 2.1 over 4. So then to solve, again, if I want to solve for my angle, I have to use the inverse operation. So theta will be the inverse cosine of 2.1 over 4. Okay, you can run all that through your calculator. It should give you the angle theta, which winds up being 58.3 degrees. Okay, so hopefully that makes sense. At this point, I know there's a lot left in this lesson. We're going to stop. It takes a couple days to go through this. This does take a lot of practice. So right now you can just jump right ahead and look at your homework. So you can see the homework split up into 2 days over here. Ignore everything on day 2 right now. Just focus on everything in day 1. Okay, and like anything, it just takes a lot of practice to get used to working with right angle trigonometry. That should give you a good idea into the basics of how this works, and we're going to focus on word problems moving forward. But for now, just work on the homework for day 1. All right, thanks for listening. Cheers.